Hello, everybody. Good morning. Welcome to this session, GraalVM Native and Spring Boot 3. My name is Brian. I'm working on Spring Framework and Spring Boot. And I meet Stéphane.
Who's doing the same.
Still. So today we're going to cover especially the GraalVM Native theme in Spring Boot 3. And that's what we're going to talk about. So quick agenda. We're going to quickly talk about why we're working and we were working on GraalVM Native support in the Spring portfolio, and then what it means for a framework to support GraalVM. And we're going to explain the strategy we've chosen, which is what we call AOT Processing in Spring. And from there, we're going to share the expected scope and limitations or things to consider when you're thinking about moving an app to GraalVM Native, as well as a quick developer cookbook to really help you get started with that theme. So first, why we chose that theme as a major theme in the new Spring Framework 6 and Spring Boot 3 versions. So first, it was a highly requested feature. It's been for quite a while. But we also want to recognize a few things. First, we want to recognize that GraalVM Native has unique runtime characteristics. So when you think about it, whatever we do in Spring, a lot of it comes from GraalVM by itself. So when you're thinking about memory efficiency, dropping from the gigabyte scale to megabyte, same for startup time, seconds to milliseconds, that's not something that we could have achieved on our own. And there's also a neat feature that you get also with the GraalVM Native, which is the predictable startup performance. So whenever you start your application, the performance and the latency you get out the application right at the start is more or less what you'd get at peak performance. It's super quick.
Some production consideration also to take in mind, like what's the use cases that are more suited to building your apps to native image. So scale to 0 comes to mind for the startup time efficiency, CLIs, serverless. So these are really the use cases that you can try first. If within your organization you have like a bit of a battle between other teams using Go or Node.js, and they're laughing at you because you're the Java people, and that kind of feeling, you may get some more, let's say, advantages to use this and potentially compete with those languages. There's also as we will see in the demo, the things that you can do dynamically in a native image is restricted. So you can use reflection, you can load resources at runtime pretty easily, but you can't do so in an unexpected way. So anything that like CVEs or anything that you didn't really intend to happen, you have this shield building your app as a native image. So
we're not going to talk in details about how GraalVM itself works and the expected qualities and trade-offs to consider. This was well covered by Alina and Thomas yesterday. I highly encourage you to watch that talk on YouTube when it's up there. But yeah, we highly encourage you to go there. First, we're gonna also share a bit of story behind this. So we started working on that theme before 2019 and started a proper incubation project for it, which is called Spring Native. Experimental project. Since 2019, we tried very different approaches, rewrote the entire engine multiple times. We've experimented with different ways of supporting this in Spring properly. Fortunately, we got a lot of community feedback, people willing to try a lot of things with us and being very patient. And at the same time, as we evolved, the GraalVM project and the GraalVM team were very much working hard and evolving the project and helping us so that we could adopt the best practices. And in the end, the goals align pretty well, and I think we're in a good spot now. And this is how we're confident today to tell you that this has reached first-class support in Spring Framework 6 and Spring Boot 3, and we're retiring effectively the Spring Native experimental project, because if you want broader support for libraries, the entire Spring ecosystem, that's where you want to be. We're going to share a bit more about this in the talk.
So let's talk about support strategies for frameworks. So for us, there is challenges to support our features in an environment like native image, because we put some infrastructure in place to call your code, usually using reflection. We are discovering components at runtime, which can be a challenge also in a native image. So there are all kinds of things that are unique to framework developers that were quite hard, and we would like to share with you what we've done.
Yeah. So if you've already tried GraalVM native, there's a native image binary that you can use to turn a Java application into a native binary, and that's a very simplified version of it. But what you can think about it is that it's looking at all the classes and your fixed class path at build time, listing all the classes, and then discovering a lot of things, performing highly complex static analysis on your application, trying to figure out all the code paths, everything that will be used or taken care of in the course of the lifetime of your application. And out of that, it's also using additional reachability metadata. So basically everything the static analysis cannot guess or find out on its own, you can help with additional metadata to tell it that you'll need stuff at runtime, being resources or classes and so on. And with all that, then compilation is performed at build time, so packing everything from code and data into a single binary and ready to start. That's basically how you can think about that compilation phase.
So what does that mean for us, and what strategy we've chosen to support Spring applications there? So there are essentially two things that we can do. On the one hand, we could work on the reachability metadata and essentially discover all the use of reflection, class loading, resource loading, and provide the metadata for all of that. So for all the possible combinations, think about all the auto configurations that Spring Boot support, then looking at all those cases and what might or might not happen, and then contribute what we call hints for that. That's one way to do it. The other way to do it is to actually look at your application and inspect its state at build time, discover the features that you are actually using, and then generate some code that represents the state of your configuration arrangement. So essentially, translate everything that could happen, every decision that can happen at runtime, such as auto-wiring, dependency resolution, and code that in code so that you just run the code and you have the output. So it turns out that actually doing one or the other is actually pretty intense. Doing only the metadata thing means that you're shipping way too much code in native image. And the processing, the static analysis can't really optimize anything because all the code paths can be reached. And that means that you get a significant larger image and more memory footprint as a result. Generating only code means that we have to translate everything that the container does for you at runtime. And that is really, really difficult because some decisions are sometimes taken based on the bean instance, which we don't have at build time, or simply about some code that we can't invoke to actually know what the output is going to be. So there is no way for us to actually do that without some sort of compromise. So what we ended up doing is actually a bit of both. So we do some analysis at build time where we inspect your application. You'll see that in a minute. So we generate a streamlined version of it, a simplified version of it, and then we also infer metadata for the other use cases that we don't want yet to translate in generated code.
So concretely, what does it mean for your application? We call that AOT processing in general in Spring. So that belongs in, so the core infrastructure is in Spring Framework, and then each Spring portfolio project also can contribute things to it, and the overall wrapping and execution of it belongs in Spring Boot. And that's what we're going to describe here. So what Spring Boot does, at this point, we created a new phase sitting right between application compilation and the packaging phase. So this is describing the Gradle tasks. So that's the names on the arrows. So what it does when you have your application compiled with the classes and resources, we have this new process AOT phase where we are looking at your application as a with closed world assumptions. We'll talk about it. We're looking at the classes. We're looking at how your application is structured. And from that, we are generating AOT source code and as well metadata, so as reachability metadata. And we're doing that at build time, and then we're compiling those generated sources. During that phase, we can also fetch the libraries metadata. So that will be the metadata contributed to a community repository for all the third-party libraries that we're not in control. And then out of that, you have several paths. So you can either have a boot jar, which is a regular jar, but with the additional AOT classes and the metadata. And something you can run on the JVM right away, or something you could later on compile to native. The two other paths are direct paths to native. The first one is native compile, so we are basically using the GraalVM native build tool, build plugins to do this. So we are compiling your application right away as a native binary, using whatever architecture you're using on your local machine, so CPU, operating system, and so on. So this is creating a binary that's targeted for your local infrastructure, and that's basically what would you use if you want to test something locally and test the binary. If you want to move something to production, then the second path is a bit better, because with boot build image, we're still using build packs, so it's the current support we have for building OCI containers. But this time, instead of pushing to that OCI container a JVM and your Java application with proper Docker layers, what we're doing here, we're not pushing the JVM, we're just pushing a native binary that's compiled for the target architecture of your container. And those are the three choices that you have from that point.
All right, so what happens in this ahead of time phase when we inspect your application? What do we actually do? So one thing we do is we actually process your app up to a point where it's ready to create bin instances. So it does not create bin instances at build time, obviously, otherwise that would be a bit of a problem. But what we do, we analyze and we scan and we generate the model of your configuration arrangement. So think again about auto configurations. What we do is, based on the libraries that you've chosen, the configuration, the profile, etc., we determine which auto configurations are going to match effectively based on the library that you've opted for. That means a number of auto configurations and code paths will be removed as a result, and static analysis is not going to run on those, which means smaller build time and smaller footprint. Based on the bin definitions, based on the state of your configuration model, we're going to generate some code that represents the state of that configuration arrangement.
Yeah, so as Stéphane hinted, we're doing things in several steps. The first part is we are operating on a closed world assumption basis with looking at your class path and seeing at the environment more or less fixed, looking at your main class. Out of it, creating the AOT code that will spin up the exact state of the container as you'd expect, as if it was running with the actual configuration annotation model. But then at this point, we're not creating beans. As Stéphane said, it'd be strange. Like at build time, if somehow the build would try to connect to your database or something like this, it wouldn't work, obviously. So we're creating that view of the context, and then we're generating source code and hints. And this will be the way to restart reapplication in the state that you want.
Time for some demo, I guess. So something that we've really focused on what we've done as framework developers, making sure that the infrastructure as you know it will work if you decide to build your app as a native image. But there is also what happens in your own code. If you have a library, for instance, within your organization that's doing like reflection on resource loading, or was like adding some stereotype to some beans, something that you do dynamically yourself, then you'll have pretty much the same challenges. And we also want to show you how we've exposed the API we use internally so that this can benefit to you as well. So anything that we've used internally to support this is also public API that you can use to extend the engine if you need to. So we have an app which actually represents in a very naive way what I've just mentioned. So there is a simple hello here where you can pass a mode, and the mode has a number of options. The first option is bean, and what that's going to do is going to do dependency resolution. So asking the container, do you have an hello service in the context? Yes, give it to me, and then calling a method to it. Then you have reflection. As you can see, it's actually doing full reflection, loading a class, calling the constructor, and even invoking the method using reflection. Then there's also a different implementation of this wonderful service that loads some kind of content from disk, from the class path, which is this file over here. And as you can see, there is a square bracket before the hello. So let's have a look to just what's happening now that it's running on a JVM. I'm doing reflection, that works obviously. I'm doing bean, that works obviously, and resource. And we said the resource, we have the bracket thing. So what we're going to do now is we're going to compile the application to native and show you how you can get started. And there is a number of use cases that's going to fail. Right.
Okay. So again, the use case that we're using right now, it's a bit contrived because usually in an application you don't often do full reflection on something that's really dynamic, or you just don't load resources at random like this. So this is something that frameworks do and libraries do, and we're going to show you how to support this if you ever need to do this. But otherwise, we're going to show you as well what AOT does for all the regular Spring applications.
So to get started with Gradle, Brian mentioned native compile, which was from the native build tools plugin, which is this plugin for Gradle. When you add that to a project, it will automatically, Spring Boot will automatically detect that, the Gradle plugin for Spring Boot, sorry. And it will add extra tasks so that AOT runs before actually native compile does, and so that essentially the optimized version is made available. Right.
So we're going to run the native compile task. This will, as you will see, this will trigger the process AOT phase as well. So the actual first compilation, then generation. So as you can see, there's the Spring banner here. So we are initializing the context, but not actually creating beans. Out of it, we're generating sources and metadata, compiling all of that, and then triggering the actual native image compilation. So while the native image compilation is being performed, we can look at the output of that process AOT phase, that new phase that Spring has, and we're going to show you what we're actually doing as a framework to help the GraalVM native use case.
So we have this entry point that represents what is going to be invoked in the native image rather than the usual configuration parsing that happens at runtime. and that's going to essentially register a flat view of the bin definitions that have been identified based on condition evaluations, environment profile, etc. And each of those bin definitions is actually structured in such a way that you can easily spot the things that have matched based on the structure here. You can see some Jackson things, some web things. It's a web application, so there's a number of things that have been identified. What we also do is we make sure that if you need a proxy, a CJ proxy, because of the stereotype that you've added on your app, a transactional ending, caching ending, or whatever, we generate the proxy at build time as well. So we identify that, we generate it, we add it to the build, so that it doesn't need to happen at runtime. Usually the proxy is created on the fly. We identify that at build time, which also prevents us to ship some of the code that's necessary to actually create the proxy.
And I'd like to underline that for us, for our own sake and for yours, we chose to, besides proxies, which is bytecode, we chose to generate mostly actual source code, which can be shipped with your jar, which is Java documented. You can actually run this application in an AOT mode in your IDE and debug step through it. And you can browse, like as Stéphane is showing, you can actually click and browse through the source code and figure out what's going on. This is, again, not only for you to understand what's going on instead of having some like usually garbled whatever where you couldn't understand what's happening, but also for us because we want to be in control of what's happening and we want to be sure that we can debug it and that the experience is consistent.
All right, so that should be it. Let's start our app. Native compile.
So okay, so now we're running on that first instance of our GraalVM native application. It started pretty fast, as expected. And even though, like Thomas said yesterday, we shouldn't really trust that number. You should really measure it in a different way, in a proper way. But first thing is, like you've seen, the application started. We didn't do anything special with regards to configuration, Spring Boot, other configurations, our web controllers, etc. If you try this, it's going to work because the application context, the beans resolution, everything that's on our side, and that's not something you have to worry about. This is supported out of the box. So there, you don't have to do anything. That's why the AOT phase is here for. This is to support all those cases and all the expected features in Spring.
Yeah. So that bean that was retrieved from the object provider is defined here. The demo configuration was identified using class path scanning. The usual stuff. We actually run the exact same code path at build time, so we do the class path scanning exactly the same way to the same code, so that we can make sure that the outcome is consistent. However, if we start like doing something a bit more funky within our application, that doesn't work, and the error that we get is, I don't know simple hello service. I don't know this. I don't know this class. And the reason why GraalVM doesn't know this class is because the static analysis could not find that at some point you would load that class dynamically and you would try to instantiate, create an instance using the default constructor. So just say, okay, I can't do this.
And this is native code, but as you see, you're getting the expected traces, stack traces, so that you're not getting some kind of native error message that you don't understand. This is pretty expected for Java developers to see what we're seeing here, including here where we don't have the hello.txt resource available in the native image, so it's just a file not found as expected. So here, because we're doing something that's very highly dynamic and using heavily reflection in a way that the static analysis cannot figure out what you're using. If you're doing class for name with the class directly, with the name directly, it's clever enough to figure things out, so we wouldn't have to do this. But here we're doing things in a way that it's very hard for the static analysis to understand what we're doing. So here we need to provide a little help.
So we essentially, this is our first step, right? We have an existing app. We compile a native image. We start it. It starts. Okay, that's already good. Then we start like playing with our API. Oh, nice. And things are not working. It's not rebooting, so it's already dead. That's not really a great experience, right? It would be nicer if you could at least figure out what may or may not work in your system for maybe running your tests and having some sort of validation. So that's what we wanted to provide, and we wanted to provide it in such a way that you don't have to rewrite your tests. So here you can see that there is a, for those who knows the slice test, so it's a MVC focused test on the starting the web layer, and then it's doing a bunch of call to the controller using mock MVC, and it's making sure that, you know, whatever output we have is the one that we want. So the support that we have in testing in Spring Boot 3 is so that you can actually run those tests in a native image.
So yeah, because the alternative would be you'd have to somehow to write some acceptance tests that are just looking at your production application or like compiled application and just run external tests. So you'd be losing your entire test suite, you'd be losing a lot of flexibility. And here, if you've got existing applications and you're considering pushing them and targeting the native deployment option, then you already have a pretty good option to figure things out if things would be working or not.
So the way this works is, as you know, when you're using the Spring extension, your test is actually starting an application context that represents certain characteristic of your application that you've opted in for. So for instance, the WebMVC test will only select certain auto configurations, give you an MVC container, and you can use mock MVC to call it directly. The test phase, so the process test AOT phase that we've added to our plugin, is doing exactly the same as the app. It's identifying all the contexts that your test expose, and then for each of them, it's running the AOT engine on it. So for each of them, that's why you have the 001 thing over there, because we only have one context. But if you had more than one, you would have like more of those code. That is passed to native image. And there's also special instruction when native image builds the image for your test that it should use the optimized version rather than, you know, whatever the code is doing at runtime usually. As a result, we have a native image with all your tests in them, and at the end, the native test plugin will start the image essentially, which will have the effect of running your tests, which is what's happening now, and it's failing. And we have like 2 tests failing, and we have our exceptions here. So the hello.txt and the class not found. So that's a much, much easier way to identify in which state your application is.
So at this point, we've got our test suite failing. We know what's going on, and we're going to give you. We're going to talk a bit about the what you'd expect, which would be supported in app and how, and we're going to try and solve those problems a bit later in a second demo. So if you're wondering, is that GraalVM native thing going to work for my Spring app? And we're going to try and explain if it's the case. So the first thing is we are relying on closed world assumptions, meaning if you go to GraalVM native image with Spring, you're losing some of the runtime flexibility. Why? Because if we want it to be somehow efficient and we want it to be reliable, we need to make some assumptions. The first one is that we want to fix the application class path at build time. So unless you're dropping jars at runtime in your application, it shouldn't be much of a concern for you. But here, that's the number one assumption that we're making. The second one is the Spring profile that you're choosing is also fixed at build time, and I'm going to explain why. And the third is actually the second, in just another way of saying it. Every environment change that impacts the application context is not supported, meaning if you have Spring Boot properties like Spring some feature enabled.true or false, those are fixed at build time. Why? Because as Stéphane explained earlier, if we didn't do that, then we would have to ship mostly, like almost all the auto configurations of your application. So even if a feature is not being used, we'd have to compile it, we'll have to ship it with a native image, and you'd pay the cost of it, even though you would probably never use it in production. So those are limitations, but for all the other properties, like server port, everything that basically doesn't add or removes a bean from the application context, all the others, they can be changed at runtime, no problem.
So there's also some constraints that you need to take into account, like the fact that the Java agents are not supported. So yesterday we had a talk about Spring Framework 6 and our observability story, and we've explained that we've chosen to use a technique where libraries instrument themselves using a thin layer API, and we're not using the Java agent option for that reason, obviously, the fact to maximize cases where this can be supported. If you're using a Java agent in your application right now, that could be a concern moving to native image. And if for some reason you're reading or manipulating bytecode at runtime, don't do that, ever, and you'll be fine.
I mean, technically, you can probably do a lot of things with GraalVM. Like it's very clever, and you can support a lot of things. So there might be ways to do that, and we know there are ways to do this. It's just that our advice from a Spring application perspective, if you try and do that with Spring, you'd lose quite a lot of a benefit. You'd lose like compilation time, you'd lose performance, and you'd lose like a lot of the assumptions that we're making. So we think that it's a safe bet to make, and that's a safe assumption on our side.
And kidding aside, if you really need to manipulate bytecode for whatever reason, you can do so at build time. So it would be an advanced use case of the engine. Like the use case of actually generating code right now is not really it's public, but it's not really supposed to be used externally to the Spring core. Actually, none of the portfolio module in the portfolio, except very specific places, have implementation of those interfaces. So the code generation is really in the core only. They're not doing like anything fancy in Spring Security, Spring Data, or whatever. It's really the inference of the engine that works on all those projects.
Yep. So when it comes to third-party libraries, because Spring projects, our job is to basically interact with a lot of libraries in the Java ecosystem, supporting a lot of use cases and features. When it comes to third-party libraries, we cannot contribute to them directly. Those metadata or our own infrastructure, it wouldn't be possible. So libraries can still contribute reachability metadata to help the static analysis. But not all library maintainers have the time nor the bandwidth to do it right now. But what the community can do is to do this for them and help them until they're willing to maybe do that thing in the project. So what we're doing at the Spring level is whatever third-party library we are supporting and we're working with, we are writing metadata, and that metadata we don't want to contribute to our own repository because given the number of libraries and versions we are supporting, it wouldn't be sustainable from our perspective. So we are contributing then to the GraalVM reachability metadata repository, which is a GitHub repository where the entire community can contribute metadata, given it supports, it's respecting the ground rules for the metadata, and also contributing tests. So all the metadata there are battle tested. And we are working as well with other frameworks to contribute metadata there for all the libraries of the Java ecosystem.
I've just realized that we forgot to show you what it looks like. So metadata is about reflection, resource loading, serialization, and the need of JDK proxy. There's also some support for JNI if you're using this. So this is an example of reflection where we're explicitly stating to the native image that a class needs to be, in this case, the one here, this entry means that the constructor with no argument needs to be available in the native image, even though the static analysis didn't find that such a call would happen. If we look at the resources, it's mostly about things that we know the core container is going to load. So for instance, the mime type here or codec configurer, which are files that we load to configure things. But there is also like additional things that your application may need, and this is what's happening with the hello.txt. It's not in this list, so that's why it's not pick up.
So yeah, that data you don't want to write manually. But when you look at it, there's nothing magical about it. It neatly maps one-to-one with the Java reflection API in most cases. If you're doing class, get declare methods, for example, that's something you would find in the metadata for a given class, let's say. And yeah, one thing with the long-term goals. So we're describing the current situation, but this is not where we stop as a community. So again, ideally, libraries would work on this and would contribute it themselves. Some libraries already do, like Netty, and the community is helping them to have something very efficient. But this would not stop as well with that metadata as a JSON format. People are working, the GraalVM team are working on maybe baking this feature in a different way, so maybe not as flat files, but maybe in the code directly through annotations or keywords and whatnot. So just ways to make it, if it's in the code directly, it'd be easier for the static analysis to figure out, so that would solve a lot of problems. So there's a lot of work there going on. This is not the end.
So we've seen one thing that you can use to test your native application, but there's more strategies to use. So the first thing that you can do, as Brian mentioned already earlier, is running your app on the JVM with the AOT artifact. So there's a property that you can set, which is spring.aot.enabled. And if you set that system property when you start the app on the JVM, it will take that shortcut of using generated code rather than doing all the configuration parsing and whatnot. If that fails, it probably means we screw up something, right? It's not supposed to. So if it fails, please consider raising an issue in the Spring Framework issue tracker. It will help us to improve the engine. We also have a number of testing utilities around hints. We will show you also the API that we use to generate those files. So those files are not created by hand, obviously. We have an API behind it that you can use as well, and some tool to also help for common use cases. We have runtime hints predicate, which can be used in unit tests if you want to make sure that the hints that you've contributed match certain criteria. And there's also an agent, a Java agent, that you can use in your test to actually make sure that whatever is happening within a Lambda is actually matching your expectations. So essentially you set up your hints, then you record some piece of code that potentially that controller, for instance, could be an example of it. And at the end, you can ask if the recorded reflection, serialization, and whatnot match actually the hints that you've provided. You can execute your existing test in a native image. We've shown that, and there's also some great debugging capability that's coming up in IntelliJ IDE. Unfortunately, the ultimate version only.
Okay, so now let's fix the issues we have in our application. So we're going to start with what the reflection bit.
Yeah, let's do that. And so to do this, there is several options, but let's just show you the fully programmatic one.
Yep. So what we need is a way to tell the AOT infrastructure in Spring that we're going to do reflection on some classes. So the manual way would be to write the JSON somehow or use the GraalVM tracing agent to generate that, but maybe you'd get a lot of it, so maybe not what you'd expect exactly. And also, as we're going to see, you definitely want to target and contribute that metadata only when it's needed. So in our case, we are going to do have a runtime hints registrar where we're going to provide runtime hints. So the runtime hints API, this is where we are contributing hints about reflection in resources and proxies. So here Stéphane is registering a constructor because we are instantiating this class with its constructor, so registering the constructor for invocation, and as well, right after that, we were calling the say hello method directly, reflectively. So the same thing, we want to register that method for invocation at runtime.
So there's two modes that you can use with GraalVM. There's the invoke and introspect. Introspect is much more lighter because you don't need to ship the code that actually lets invoking the method dynamically. Invoke is about like if you want to look at characteristics of the method, etc. But in this case, we need the invocation. So that would fix the reflection case.
Yeah, but now we need the resources. So in our case, we only have one, and we somehow need to tell through the metadata, we need to tell that we're going to need it at runtime. So here we're using the resources and we're registering patterns. So here it's a simple pattern, it's hello.txt, but you can do a bunch of things with Java regex patterns where you can say everything under that folder, everything with that extension, and so on.
So we need to register our implementation.
Yeah, so this way, when you're doing import runtime hints, you're declaring it because it needs to be declared on something that is considered by the application context as a bean or as a configuration. And when it does, this will be only processed if the Spring analysis, the AOT analysis is reaching this particular configuration or bean. So the added metadata will be only done if the Spring context will use it.
Okay, so there is no, let's maybe run the tests again. That would be a good way to see if that's fixed.
So it's processing, it did the processing, it's now compiling the test, and now what we should do is that we should see the additional sources and in this case metadata that we're using. So here the simple hello service, it's being registered with the init, so init method, the constructor, as well as the say hello. So that API, that programming model that we've shown, it's basically the equivalent of doing this manually or using an agent to write it. Same for the resource pattern where it's converting our hello.txt in a proper pattern, and this is adding that automatically to the metadata.
It's also worth to notice that you've seen us like actually getting the constructor manually and using reflection utils to find a method. Usually that's not what's happening. You're within a piece of code that's actually looking for certain use cases based on an annotation that you have or some feature that your library provides, and you already have the method as an argument because that's the output of whatever scanning mechanism you have. And then you can pass that through to that API directly.
Yeah, and what we're doing here is actually quite similar to what we've done in Framework with different utilities still. But for example, for Spring MVC, we've got infrastructure that goes through all your controllers and make sure that those controllers can be inspected and the controller handlers, those methods can be invoked at runtime reflectively because that's what Spring MVC is doing. But it's not very different from what the general Spring support in all the Spring projects look like.
So in this case, we can, as Brian mentioned, we do more than scanning just the configuration. We actually scan the structure of your component. In this case, we scan the controller. We can see that we have a mapping that actually returns an object. So we automatically contribute metadata for that object because we know that that object, because of the structure of the controller, is going to be serialized. So that you don't have to deal with this. So everything that's in the type signature level, we're trying to infer. It might not be 100% covered, but if you have like use case that don't work, please raise an issue. The idea is that if you used the framework contracts, things that needs to be inferred will be inferred. That will not work for things that you do internally. So an example of that would be you have a piece of code, and within that piece of code, you use the web client to call some service, and you ask the web client to deserialize the response into my object. In that case, because it's within your code, there is no way for us to infer that my object is going to be deserialized. So for those cases, you need to handle that yourself.
Yeah, because what happens is, if you're, for example, using Jackson will be using reflection on that myObject.class to use the setters, figure out the annotations, if there are Jackson annotations on it. So you would need to register the proper hints for this, and we have utilities just for that.
So let's have a look, for instance, for the reflection use case. Another thing that you could do is something like that. And that will automatically register my object, whatever it is, for binding. So it will be inspected and the relevant metadata will be generated automatically. We also have like more advanced API for this. So for instance, we have an API where you can tag a method as being reflective, as requiring reflection, and it will automatically infer the necessary metadata.
Okay, so now we should be done with the test. I saw that.
Yeah.
So now all our tests are successful. We know that it works in a native image, and we've done what we needed. So we're going to summarize what you can do when you want to start with an existing application and when you want to try it into a native environment. So if you want to follow a recipe, first bit is you can try executing your existing application in AOT mode. So adding the build plugin, doing the processing AOT, and then running your application with the spring.aot.enabled flag, system property.
Yep.
And that will run the application with in AOT mode. If everything runs, the first good step, it's all right. If it doesn't, please raise an issue. The second one, you can, as we did, you can run your existing test suite in native. You'll find out problems. Some of them are from libraries, some of them are from your own code. If it's from a library, then you can look up the shared metadata repository and consider contributing hints to it. It's not that hard. You can look at what the other what we did for other libraries. It's basically contributing tests and writing some JSON. If it's your own code, then you can do what we did, registering runtime hints. And because we don't like to write code that we don't test, we're providing a lot of testing infrastructure around it, including a runtime hints agent, which is a Java agent we're using in our own test, where we are wrapping some bits of code that we're executing, and during those bits, during those execution steps, the agent is checking all the reflection, all the type of reflection and things that might need metadata at runtime, records all them, and ensures that the hints you're contributing to your application are in line with what the agents recorded during execution. So it doesn't require compilation to native. It's a nice way to go really far on the JVM in your test. As for the last bit, if you're really doing something very advanced, then you can generate code with the facilities we have in Spring Framework, and you can even test them with a test compiler within the JVM, where you'd get the sources, it would compile it just like this, and you can even execute the thing. So in this case, we were generating source files, and from those source files, those are getting compiled, and within that lambda, you can use the code that was compiled directly. So this is a neat way within the JVM in your test to test the source generation. But again, out of all the Spring libraries, Spring Portfolio libraries, very few do that, like framework and maybe data.
There's a bit like if you're playing with the context dynamically, like if you have child context and stuff like that, yeah.
Yeah, but most Spring Portfolio projects don't do this. Hopefully you don't need to.
So we're testing already a bunch of things. So we have a smoke test repository. So this is only one small bit of what we have. So we're trying integration with all kinds of libraries, making sure that they work and you get the proper user experience out of the box.
Yeah, and that's basically our own goals. We want to ensure that GraalVM native can be adopted by the entire Spring community. We want to make sure that most existing apps can consider that as a perfectly viable target deployment. We also want to be good GraalVM community citizens. We want to contribute whatever we can. We want to make sure to send feedback to the GraalVM team and to make sure that it's properly adopted by the Java community. And our goal, anyway, for all the major features we develop in all Spring major and minor releases, is we want to bring new use cases and new ways, new target deployments to developers. We don't want to force you to do anything. If you consider that this is a neat thing that you could use in your own projects, we want to make sure that it's something that you can use safely.
If you're interested by other features that's coming up with the new major generation, we had a talk yesterday discussing about other things like observability, the problem details RFC, Java interface clients. So if you haven't seen that, it will be available on YouTube shortly, I'm sure.
Yeah, and this GraalVM theme in the Spring projects, that was a major request from the community. If you want to influence the next big thing we'll be working on, please consider participating in the State of Spring survey. This is something we do yearly. We like the community to contribute opinions and vote there to make sure that we're hearing you properly.
Time's up.
We're right on time.
Thank you.
Thanks.